Okay, so today we're going to go over 3.2, which is slope and rate of change. And so, so you're going to fill in the blanks to describe the linear models. Okay, and so a linear model is a mathematical representation of the real world relationship between numbers that change at a constant rate. Constant just means it doesn't change. And rate means it's kind of like miles per hour. So a linear model can be written as an equation, a graph, or a table. Okay. And then it says the rate a plumber charges is described by the function y equals to 21x plus 45, where x is the number of hours and y is the total charge. The slope of the function, now, if you look at this and you recognize this as y equals mx plus b, you're right on. So then that means m is just 21. Right? So that's just going to be 21. So m is 21. Where the real world meaning of slope goes like this, right? So the rate a plumber charges is described as a function of y equals mx plus b, right? Where x is the number of hours and y is the total charge. So if x is the number of hours, right? And you think, oh, they worked for 2 hours, then you're multiplying by 21. So that means 21 is the dollar per hour, right? This is the dollar per hour that the plumber is charging. Okay, the y-intercept of the function is this. Now, again, all you're going to do is play matching. So that's b. And so that's 45. Right? Right. So b is 45, which goes right here. So the real world of that is basically the flat charge that if he goes out for 1 hour, you're still going to have to pay this $45. Or if you go for 4 hours, you're still going to have to pay this $45. So almost like, think about it, it's like the call fee. Okay. The call fee. Some people call this the initial fee. Oops. It's the initial fee. Okay. So it says complete the statements to show how to find slope and y-intercept from a graph. So again, if you're looking for y equals mx plus b, right? So here's y equals mx plus b. B is our y-intercept. Y-intercept. So that's when x equals 0. So it's literally where the line crashes into your y-axis. So it's this guy right here. So this guy right here is my y-intercept. Okay. My slope, on the other hand, is going to be like rise over run. So my slope is going to be rise over run. And I'm going to find that on my graph. So first of all, I find 2 really good points here, and here are 2 good points. And then I'm going to count how many floors I have to take on the elevator, how many floors I need to go up on the elevator versus how many numbers blocks I need to run over, let's just say. So up is 1, 2, 3, 4, and over is 1, 2, 3, 4, 5. So my slope here in this case, m equals 5 over 4, rise over run. Okay. Okay, so to find the slope, use any 2 points on the graph of the function and the slope formula, m equals 2. Okay, so here it's any 2 points. If you wanted to use this point and that point, it really doesn't matter. And the formula that you learned before looks like this. It's y minus y over x minus x. And this is just taking a second to catch up. So it'll show up here. The slope of this function we already said is 5/4. So it's 5/4. Where the y-intercept is the point that. So in that case, that is the point 0, -2. Okay, so 0, -2 is my answer. And this is just catching up. So 0, -2 is my answer. And it's the point where the line intersects the y-axis. Where the line intersects the y-axis. Where the graph intersects, oops, the y-axis. Okay. All right, let's move on. It's still kind of showing up slowly, so I'll leave it up there. Okay, so fill in the blanks. It says the blank of the graph is called the rate of change. And hopefully you're like, oh, I know what this is. This is slope. Let me push this to the back. All right. It's showing up. There it goes. So here, there you go. And there you go. So here we're going to type the word slope. It's not showing up. All right, let's try another thing. From another notebook, maybe it's going to work better. Okay. There it goes. There it goes. So the slope, let me make it a tad bigger. Highlight it, make it bigger. Oops. That's good enough. And there it goes. Now I can make it bigger. Okay, and then it says to find the unit rates of change, divide the outputs by the input. Or another way to say that is just, this is not working at all. Okay, here it says outputs. I'm just going to write because it's not doing anything at all. Inputs. And up here we have outputs. Let's see if that'll work. It's not working. Okay, well, this word is outputs and this is by inputs because you're dividing the y's by the x's, right? Okay, it says the inside of an office building is being repainted. The graph shows the amounts of paint required to cover varying areas of wall space. The slope of this function, so I'm going to pause this right now and I want you to calculate what the slope is of this equation, of this line. Okay, now that you're back, the slope of this line is actually 400. And the way I got that was when I rose, I counted, and each one of these lines here is 100. So I counted 100, 200, 300, 400. So that's 400 over, and then over down here, right? Each of these is just worth 1. So this is 1. So my slope is 400 divided by 1, which is just 400. Okay. And this is going to catch up eventually, and you'll see it. There it goes. Okay, so the rate of change is measured in blank per gallon. Well, the rate of change is the Y number, so that's square feet or area over gallons of paint. So it's in square feet per gallon. Okay. And the painters use paint at the unit rate of 400 square feet per gallon. 400 square feet per gallon. So what does that mean? For every 400 square feet, they have a gallon of paint and they need to use it. Does that make sense? And you could see why that might help you, a painter, understand how much paint it takes, because that's how much paint he needs to buy, right? So fill in the blanks. On the graph, the point where x is equal to 0 is called your y-intercept. And the initial value of any function is the y value of that point. So it's the y value of the y-intercept, okay? So fill in the blanks and interpret the y-intercept. It says, Kevin wants to purchase some baseball cards. The graph shows how much money Kevin has after purchasing a number of baseball cards. So here's a bunch. So this is how much money he has, and this is how many cards he has. So here it says the y-intercept of the function is the point. Now, where are you looking? Where are you looking for the y-intercepts? Hopefully you're looking where the line crosses the y-axis. So that point, that's my y-intercept right there, which in this case, it's going to be 0,70. So that's my y-intercept. And I like writing my y-intercept as a point because that makes more sense, right? Okay, so then this says the y-coordinate of the y-intercept, the y-coordinate of the y-intercept represents what? What does that 70 represent? Well, that's how much money he started with before he started measuring whatever. So that's the money Kevin has started. Oops, I don't know how to spell started with. Okay. Okay, last little part here. So fill in the blanks to find out how to find the rate of change in y-intercept from a table. So the rate of change is the difference between the two y values divided by the x values. And they said that earlier in a different way. They said the outputs divided by the inputs. I say rise over run. They just want you to know all the different ways that you can find it. So then it says to find the y-intercept from a table, find the input-output pair where x equals to 0. Right? Because that's what y-intercept means. If the y-intercept is not on a table, then extend the table or the pattern so that the table now includes the input-output pair where x is equal to 0. So you're going to go backwards or go forwards or whatever you need to do to get x is equal to 0. Okay. All right. So fill in the blanks to find the slope of the y-intercept from the table. Both tables represent linear function. So in this table here, the slope of the function is what? So in reality, they told you the rate of change is the difference of the y's divided by the difference of the x's. Okay, so you want me to subtract the y's. So that's 11.5 minus 5.5. That's 6, right? And then subtract in the same direction. So I went 11.5 minus 5.5. So I'm going to go 3 minus 0, which is just 3. And to find the slope, you just divide those two numbers. So it's 6 divided by 3, which is 2. Okay. So that'll show up pretty soon. Then it says to find the y-intercept of the function. Well, y-intercept means when x is equal to 0. So I'm looking for 0 on the x side, and it's right here. So that's 5.5. So that it's 0, 5.5. And I do write it as a point to remind you that that's what the y-intercept means. The y-intercept means when x is equal to 0. So we're going to do the same thing here as this thing catches up, and I'll show you the answers so that you can see them here. So the slope of the function is what? So again, how do you do this? So I'm going to have you pause the video and you calculate this, and then come back when you know the slope and you know the y-intercept. Okay, now that you're back, what we're going to do is we're going to calculate the slope and the y-intercept. So it said to subtract your y's. So again, I still subtract right minus left. So negative 15 minus negative 12 is, let's see, negative 3. And 2 minus 1, that's just 1. So my slope is negative 3. okay? My y-intercept is when x is equal to 0. Now, as you can see here, I can't find 0. So you're going to find the pattern, which we just did, right? Going this way, we're just subtracting 3. And then I'm going to squeeze in my 0 here because that's exactly where we go. So as I put my 0 here, I want to know what number match, what's the y coordinate for that? Okay, what's the y coordinate for that? So let me just sync my notebook really quick. Okay. And it's still not coming. So we'll just continue. So if I had to go before and going this way, I'm subtracting 3. The question that I really want to ask myself is, what minus 3 equals 12? What minus 3, so what number here, when I subtract 3 gives me 12? Or another way to think about it is if you're subtracting going this way, that implies that you're going to go add to go this way, right? So I'd add 3 to negative 18 and then boom, I get negative 15 and so on and so forth. So here, this number right here would be what minus 3 would give me negative 12, or negative 12 plus 3, which is negative 9. So my answer here is negative 9, oops, as a point, 0, negative 9. Okay, and I'll let that catch up to you as well. And then it says, so fill in the blanks and interpret the y-intercept. The table shows how much gasoline is in a car's tank after traveling a number of miles. It represents a linear function. So the y-intercept of the function is what? So what does y-intercept mean again? Oh, it means when x is equal to 0. So that means it's the point 0, 12.7, right? So what does it actually mean? What does this number 12.7 mean? What do you think that means? Well, hopefully you said after driving 0 miles, that's how much gallons in my tank. So it's how much gallons of gas are in my tank after 0 miles of driving. Okay. So I'll let that catch up. It says fill in the blanks and find and interpret the rate of change. The table shows how much money a teacher spends purchasing markers. It represents a linear function. So 1 set costs $5.75, 2 sets cost $11.50, and so on. The slope of the function is what? Okay, well, if you remember earlier when we were finding our slope, we were subtracting. So it's 1150. And if you really understand this, you know that we don't have to subtract. Minus 575, right? And then so when I subtract, I get 575. And that makes sense because, right, the first set of markers cost $5.75. The second set would also cost $5.75. Right. Okay, so then the slope of the function is $5.75. The rate of change is measured in dollars per marker, I guess, or sets of markers. I'm not sure. It just says markers. So we'll just say dollars per markers. And then it says the teacher spends at a rate of $5.75 per marker. Now, I don't know if this is a marker set, like, you know, how they come in boxes, but according to this, it says 1. So I assume that it's just 1 marker. All right. Hope that makes sense to you. Have a great day.